Great. Welcome everyone to the second EIP-7928 breakout call. I will post today's agenda in the chat. It's rather short. We have two agenda items today. First of all, we have to discuss about do we want to include transaction indices, or how we call them now, block level access indices in for reads. So for everything that is not touched, or for everything that is touched but not modified. And the second item is basically just client updates and seeing where we at and how close we are to a definite. Right, there was a short discussion on the Discord. Some brought it up that we should include the block level access indices for S loads and for all the opcodes like call, static call, X code size, and so on that touch an account without modifying it. And the question is, should we include block level access list indices for it? So I would just pass that question to clients. What do you guys think? Maybe you can start some by telling us the motivation behind it.
All right. Thanks, Tony. Am I audible?
Yeah, I can hear you.
Got it. Okay, so the motivation is the way I envision block level access lists to serve us in the post-Amsterdam world is one of the aspects is parallel execution, of course. And I suppose that is something that most of the clients, including everyone, would be looking into and implementing because, why not? That should speed up execution to some extent. By that I mean it from our initial results with parallel execution, we've seen that something like a Merkle Patricia try might slow you down, so you need quite a bit of parallelization in order to benefit from that. That's like a day-to-day, but another potentially big thing that might happen is that you include ZK EVMs and create proofs for transactions and blocks. So when I sort of dived into this with our work for Approver, it is apparent that in order to create a proof with the current set of ZK VMs that sort of simulate running of a bare metal cut down version of RISC-V runner, you sort of don't want it to talk back and forth with DB as you would allow your regular execution client to do. So that would mean you would like to have that fully stateless. But in order for something to be fully stateless, of course, you need the whole state before and after in a block and the execution as well. But block level access list actually sits in a convenient spot to optimize maximum benefit with the least amount of space. So you would expect this kind of a setup to run alongside something that can read the belt and give you the pre-state of execution, which you would then pass through the RISC-V runner that you've got inside of your prover. And that would just one shot give you the proof after execution trace generation. So in order for you to know which state to give it, because you don't want to give unnecessary state really, because every byte of data that you pass into this very performance sensitive kind of a setup is very costly. So you'd rather just give it only the bits and pieces necessary for that tiny bit of execution to happen. One way to parallelize the proving itself would be to generate the traces and then try to stitch those traces in a GPU. That's beyond the scope of the actual execution client. But on a protocol level, you can at least say that you can create uh, transaction level granularity for parallelization, both in regular execution and for proving. So in order to do that, you would need the transaction pre-states for all the transactions because your client is, stateless. And in order to do that, block level access lists can sort of help you by already telling you which all accounts perform reads. So you can just exactly parcel your runner with that exact pre-state needed. So that is the overall motivation.
Let's see. Thanks. Yeah, to me, it feels like there is a trade-off between um, the information we add in addition to what we currently have in the block five access list. So, of course, this would make the block five access list a little bit larger. But on the other hand, we allow people who generate proofs, we don't need to pass them that much data. Because, of course, today, if you want to execute a certain transaction, what you need is everything. So all the pre-state that that transaction touches, but also the pre-state that the transaction reads. And because we don't have transaction indices mapped to what is read in the block five access list, you would have to pass everything, right? So you would have to pass everything that this certain transaction is going to modify. But in addition to that, you would also have to pass, all the values that are only read. Is that kind of correct?
Yep.
And then it's kind of the trade-off, right? Like, do we want to include more information in the block five access list, or are we fine with passing like a few kilobytes? Because here we are talking about kilobytes of data to the provers.
So I'm not sure if the like stateless execution matters so much for the provers when you look at how high the hardware requirements for proving are. I think that more the benefits are the worst case parallelism you get, right? There are some ZK VMs that are already chunking traces rather than waiting for full execution before starting proving. But that's of course like optimistic. So if you can fully parallelize everything along with having transaction gas limit, I think that's where you get most of the benefit.
Thank you. Do other clients have an opinion on that, especially when it comes to proving or parallelization? Like, how do you envision parallelization to be implemented? Would it also matter for parallelization, kind of how much data you would need to pass to each process?
So, based on the benchmarks I've run on Get on just very standard hardware, akin to I forget the EIP number, but there's an EIP that specifies a sort of a standard node specs. I've been running benchmarks against a VM that's roughly equivalent to those. I haven't implemented these indices yet, but I I don't really expect them to I don't expect it to speed up block processing in the general case. And also based on what we've seen so far, the state root computation is still dominant. So unless that can be brought down below execution. Any savings we would gain in execution don't really have a practical effect. But yeah, that's my impression.
Okay, thanks. Maybe one follow-up question. Like, it wouldn't really improve execution time. It would more be like, okay, you need to pass less data to execution, which in turn might improve execution again. But it's more like when you parallelize using the block level access list today, what data do you pass to this process? Is it like the entire cache?
We don't pass, well, in my implementation, we pass, actually, we don't pass anything. So each parallel executor will reach out to the database to instantiate whatever state it needs. And because the database maintains a cache that is shared between requests, a stateful cache, it just exists in that cache. So it's pretty opaque to us. Like there's no like shuffling around of data to the executing Go routines or threads in my implementation.
You don't need to pass the right of the previous execution to the.
No, oh, sorry. Yeah, I passed the BAL is available to these to these separate threads, but they can just recompute the state they need based on the pre-state and applying the changes in the BAL. So yeah, the BAL is the only thing that's passed. Yeah.
In business side, I
This
think
makes
if we, sorry,
No, go ahead, please.
I just wanted to say in business side, I think if we want to implement the full parallelization, I think what we will use is for on the right, only the right, something similar to what Jared did, I think. So just passing the right of the previous transaction to each transaction and run in parallel and do the read on each thread in parallel and see and compute and merge the result at the end. But for the moment, I don't really see the need of the read. But yeah. And the same for Bezos, the compute of the stateful computation is taking a big part of the block execution. So block access list only with the right will improve a big part of the block processing.
Thank you. So just so if I understood that right, then you say that you would also kind of not include the transaction index for everything that is not modified in the BAL, just because we might not need it, and we can just, or at least that's the case for your client, that you can just do it like Jared described it for Gav, where you have like access to the complete block level access list and the entire cache, and you parallelize for that. Is that correct?
Yeah. Yeah.
Okay. Okay. And this is like different for Aragon, right?
So again, as Jared said, all of this doesn't matter because MPT is the bottleneck for parallel computation. But right now, even our actual execution module, does not benefit that greatly from reads from Valve because it's not really needed. Database is fast enough at the current level. So it's the identical case for Aragon as well, that parallel reads from database through the threads is the way that it is implemented right now. And there would not be any reason to not do this because if you're only processing like, I suppose, like 50 million gas or so, the parallel reads are not that much, and you are sort of processing the block on a single machine. So your database thread, the database threads can be managed by the OS, which is hosting it. So all is good. But that's the case for everyone. It's the same. But my argument is that I don't think Valve's purpose was to enable 60 million gas or even 100 million gas. It was to maybe futuristically enable giga gas or something. So you can imagine, like when you reach that level, you would want to run a cluster of executors where it's not that same single source database that you're running. Of course, you can say that you'll have multiple databases having the entire copy of the database and so on. But I think if you can pass the data at once, you can save some time. And of course, in stateless validators, it's a big, big win still.
Yeah, that's fair. But also, for block of accesses, they do give you quite a lot in terms of scaling, because you can also basically all the worst cases we have that are not like history growth or state growth. So basically all the worst cases around precompiles, opcodes, how much storage access we can handle and stuff, they will all become better, right? Because you were probably comparing or determining the results based on average blocks. But I think it would be a fair comparison to compare it with worst case blocks, where basically you call, for example, the ModX precompile as often as you can. And with block level access lists, you should just be able to parallelize them. Yeah, but I agree. It's not like a holy grail that allows us to go to 100 million, especially if we don't figure out solutions for state growth and stuff. But this is probably a different discussion. Yeah. What about other clients?
If,
Have other?
if,
Yeah,
if I
go
may,
ahead.
I want to add one more thing. So another thing is, let's say you have an ASIC or a coprocessor, which is, maybe I can imagine the future, maybe next year or next couple of years, that you're doing quite a bit of your execution through GPUs or coprocessors, to which you would sort of have the same model of execution as we have for ZK provers today, that it's an independently running module with a very small footprint of code, and you just instantiate like 1,000 instances or 100,000 instances of that in one go, and then you just wait half a second, and like all of those GPU cores just return you the result immediately. But if those same GPU-like cores, and it's not exactly GPU, but just get the analogy. If they have to sort of depend on CPU to again go to the database and go via memory to return the results, they would not be very effective. So I think like if you have a coprocessor or something like that, even in traditional computing, valves are going to be like, if you just put the reads in, it's going to be like a huge boost for that kind of use case. And I think it may come next year or something like that.
Thank you. Yeah, this is very interesting. Curious to hear, do other clients have an opinion on the topic of including block level access indices for everything that is not modified? Okay. Yeah, right now it looks like most people are for not including them, but I definitely see the arguments. What do you think, Sam? Should we just postpone that decision and keep it as it is for now, and then maybe check with the CK people too and see what they demand?
Well, the argument is that the 2% increase can probably give you many seconds of benefit in terms of passing the pre-state, because otherwise you would have to know the pre-state in advance before trying to prove it. And like currently, there is no way around this for ZKIP people. They are happy to make a proof after execution is done. And yeah, I agree that hardware is big and all, but it would be interesting to see if it reaches more demand for these fancy use cases. So I just want this to kind of have a little extra data and be future resilient and to like not need any more modifications in the next hardware rather than just have the bare minimum and just look at how it is being done today and be happy with it. I'm okay either way. It's just that if you had this maybe at the protocol level, you get a nice speed bump. So.
I mean, I'm happy to dig more into the ZK side and ask ZKVM teams, but I'm first unclear still how this difference, like, is a difference for proving versus just validators re-executing, right? Like execution speed definitely matters significantly for proving, but I don't understand how it's more different here. Like, they're not stateless right now, right? Like ZKVM, so they're not doing execution statelessly.
Sorry, what do you mean they're not doing it? Are you saying like ZKVMs have databases inside them?
I believe that the guest programs are loading the state, yeah.
Yeah, but like you'd have to pass the state to them after executing somewhere else statefully first. Then you have to do that because there is no provision like block level access list as of today. But after block level access list, you still have to continue to do this, which is like to generate something like block level access list plus all the values populated, and then you can sort of generate the execution trace and the proof. So yeah, currently they don't do it because they don't have it. I'm just saying like after BAL, they will still not have it and still continue working in this way, which maybe we can do a little bit better with.
Yeah, I'm saying that I'm not sure that that's any different from what an attester that's re-executing and not proving the block would do, right? Like.
Okay. Another clarification. Okay, in my mind, we don't have two executors. We only have vals and the prover that does one-time execution only. So it saves you like the first execution time entirely, not within the prover, but like outside of the prover that you use to generate the trace in the first place. You can just get rid of that because the val is the kind of the trace that you are missing today, that you have to generate before generating the proof.
Right, but so when after Glamsterdam, right? I assume that the majority of attesters will be right. Yeah, it's sort of like what Kareem is saying. Like, well, I mean, I think it will be in production, but it won't be like the norm, right? For attesters to use, they'll still be re-executing, and it should be faster with vals. And I don't think that that is any different from what a prover, from the considerations that a prover has in terms of execution. or at least with regards to the issue we're discussing now.
Right.
Yeah, but they won't be able to use the belt effectively. Is my argument that if they have, I know they'd be happy with it, but like, why not make it easier for them to use it with the read
Right. They
values?
would just not
So you don't
they
need
would just not be able to use it that efficiently, right? Because what a prover needs in order to, let's say the prover wants to prove the last 10 transactions of the block, then I would need to give the prover the pre-state of the block, then the block level access list, so that the prover can arrive at the state where he starts from. And I would have to give him everything concerning read values, so everything that is touched in the block, because I don't know in which transaction it is touched. So I would need to give everything to the prover. And this is like what you're describing here, right? That
exactly. Yeah.
that instead of pre-filtering which exact values the prover will need for those specific transactions, I will have to give him everything and be like, yeah, the right values will be part of the set I just gave you, but I can't yet tell you which exact read values you will need. And I can definitely see that because, yeah, in a world where you would do some distributed proof generation, then you would of course need to send that over the wire. Yeah, I think it's a valid concern and a valid argument to include the transaction indices. As said, it would add like 2% of additional size, looking at the snappy compressed block level access list size. It would definitely save like kilobytes of data that will not be needed to be passed to the approver. It's the question of is it worth it, right? Because those 2% would go into history, whereas the additional kilobytes provers need to send over the wire, we don't really need to care about it that much. So yeah, it feels like we need more answers from CKVM teams. So it would be great if we can reach out to them and ask what they think about the current block level access list design, and then we can still like add the block level access list indices. So right now I have already spec'd it. If you look into the Discord, there is a spec implementation. It's kind of trivial to add the transaction indices because all the code exists that tracks that. It's just it adds a little bit more of complexity because now we have like edge cases where a transaction we don't include addresses and their transaction and the index where they are touched if they are modified in the same transaction, right? Because otherwise we would have duplicated values. So I think it adds some complexity, but it might be worth it. Is there anything else someone would like to add to that topic before we close that one?
I would also like to know if there is someone against it completely, because there might be something that I'm missing.
I mean, I wouldn't say I'm against it completely, but I think we just need to be like very careful adding things with like unclear payoffs. I think we need a lot more data before we commit ourselves to something like this, because once we have this in the protocol, there will be someone who uses it, and now this is complexity we have to carry around forever. Like I think we need to like very clearly understand the trade-offs, and I think we're quite far from that, and I think we're like over-indexing on exactly what we expect ZK things to potentially look like in the future. But it's just very unclear to me that this is the right thing to be adding and shipping right now. I think like we should rather be a bit more conservative and focus on like the simplest version without this, and then rather focus on getting the like actual scaling benefits. Like having client teams that like implement like the marginal scaling benefit from block level access lists, rather spending the time on that over implementing this, I think is a much better use of time, just given what we know for now. That very likely may change though.
Well, I'm not sure I fully understand the gain that you get from including these or not, but theoretically, like it should be the same scaling benefits for clients not in a ZK world, right? Unless people are saying that you're so bound by state root computation that we've exhausted the benefits of proving or improving execution for now.
Right. Yeah. 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 I think in the average block, there's still the state root computation that is the heaviest part. For worst case blocks, you might get different worst cases. So suddenly execution or storage or something might become the worst case. But yeah, it feels like we don't have enough answers yet to really take a decision on that. It would be great to get more answers from CKVM teams, how they plan to use that. I would stick to not including them for now. If we still want to include them, it shouldn't be too difficult because it's basically just adding transaction indices to storage reads, and of course the transaction indices to the account object that we have, basically the changes object. And yeah, we can still add it at a later point. I think it would not be too late because it's a rather small change. But yeah, in this case, I would say we just stick to how it looks, how it is today, and yeah, just reading the chat. Yeah, I agree with Karim there. Awesome. Perfect. Yeah, maybe just to add, the original motivation to not include transaction indices at everything that is not modified was because you actually don't need it for parallelization. Because if it doesn't change, then the value you have in cache is still correct, and you might not need it. But yeah, let's see if we have to revisit that in the future. Anything else someone wants to add? Great. Then I would suggest we just go through all the clients and see where people at, if there are any blockers, and also see how far we are in terms of getting closer to a first effort. Can we just start with you, Jared? Gav?
Yeah, sure. Yeah, so I'm continuing to work to get the changes merged in Geth. Not really much of an update in terms of the performance since I gave the numbers from the prototype on the last call. Yeah.
What's your estimate regarding a first effort?
I could have a branch ready fairly soon. Maybe like a few days to a week at minimum.
Yeah, I guess it will only make sense if we have at least a second client pair, but this is great to hear. Okay, thank you.
Yeah, it's going to take longer
go
than
ahead.
that to actually get it merged in Geth, though. But yeah. Anyways.
Okay, thanks. Let's do Aragon next.
No updates. Mark from our team would be working on it. He's trying to improve our Merkle quadration try calculation, which seems to be the bottleneck at the moment, but no concrete progress there.
Cool. So you're already looking into the parallelizing the state root computation. Did I get that right?
It's already being parallelized, but we have observed that it can be optimized quite a lot, or at least needs to be optimized. Something to do with our database that when you have, so we have some block STM parallelization that improves execution time already without the vals, which is by 2.5x or 3x. It's very close to what vals would allow you. But then you hit, like, at the same time, when you start your parallel route calculation, that takes way longer, which it doesn't make sense. So we'll have to do some work on that. Yeah.
Great, thanks. Then let's do Nethermind next.
Hi. So progressing on the block access list construction, and most stuff seems to be working around all the system contracts, withdrawals, but I'm still looking into one edge case around reverted transactions. But I think it shouldn't be too long until we're able to join a DevNet. Just had a quick question on, like, what's the state of tests at the moment? Are there any tests that I could run?
Yes, there are. I would forward that question to Felipe if he's ready.
Yeah, I could speak about that. We released the first pre-release at the end of last week, but there were some issues on the spec side that needed to be updated, and I believe that they have been. And there were some things on the test side as well. This should be ready for another release, and we could get it out as soon as after this call. All the code is already in place. We just should get some sanity checks there, and then yeah, we should just get out another release so we have some good test vectors.
Awesome, thanks. Then let's continue with Ref.
We have run the initial tests, and as of now, we are looking closely into the edge cases to make sure we are not kind of misusing any. And also, we are working on cleaning up our existing implementations and sort of including the other parts as they come.
Awesome, thank you. What do you think regarding first DevNet? What is kind of the rough timeline or the planned timeline?
As of it, we will take some time. Like we have certain parts ready, but as of now, concerning indices or other parts, we need to discuss it with the team and see whether if they have some sort of opinion about what they want to do regarding it. So it will take some time. I can say about week or two for us to like have things ready. Right?
Perfect, thank you.
Thank you.
And then Besu.
Yeah, so no big update. We had to work on something else, but yeah, for the moment, we still have the block access list creation. And this week, we will work on the state root computation optimization thanks to block access list. So this is the next topic we'll work on. And yeah, that's all.
Great, so you would already be ready for a DevNet in this case?
So we have block access list creation, not block access list validation, but I think we will be able to propose block with the block access list. I'm not developing, I'm not the guy who is working on that, but I can ask the guy who is working on that to verify that it's something we can do. But yeah, I think we should be able to propose block with block access list normally. Yeah.
Awesome. Thank you. Yeah, it's great to hear. It feels like we're getting very close to a first effort already. We're not in a rush, of course. And yeah, I guess if we get to a first definite by end of month, would already be a great achievement.
I think for the end of month, yeah, it will be okay. Yeah.
Cool. Perfect. Did I forget anyone? Great. So, is there anything else people want to discuss before we wrap up? Maybe just to add, I was also discussing with, of course, because the block level access list is now in RLP and not in SSZ anymore, we cannot prove anything against it. And it would have been kind of handy for pre-confirmers. So the question came up is like, how big of a deal would it be to treat the block level access list similar to receipts, so that we put them into a try and allow proofs against this try instead of only the block level access list has. This is like, I would assume, a bigger topic and a rather big change, but I just wanted to bring it up so that people can discuss it and
Of past
for
block level
example,
access lists.
yeah, for example, and then you could do a MPT proof against this try, and it would be easier. It would be a shorter proof than providing the entire block level access list.
Yeah, it seems doable.
Yeah, I can put it on the agenda for the breakout call in 2 weeks. We can discuss it. Definitely, for sure, it needs to give us some big advantages to be worth the changes. But yeah, let's see. Great. Is there anything else someone wants to add? Otherwise, we would just wrap up. Awesome. Then thanks everyone, and see you at the next breakout call in 2 weeks.